All right, welcome back. We are Game 2014 in the fall 2021 semester, and it's week 5, part 2 of our broadcast. And this week, again, so far I've been talking about object pooling. What I want to do is I want to continue with our example on Unity. We've been working with object pooling. We created a very small game example that I'm sharing with you guys on GitHub, and I'll share the final link for the final version later on. Mary, I see your comments. Can you hang back after class, and then I'll kind of discuss that with you, okay? All right, so let's continue with what we did last time. So we were here, and like I said, we have a very simple enemy structure where the enemies kind of appear randomly and they kind of move and are predetermined. Pretty simple. What I want them to do now is fire a bullet. So we're going to modify the enemy behavior class so that it fires a bullet, okay? In order for my enemy to fire a bullet, I need kind of a position for the bullet to come out of. So let's add in a new capability for the enemy. So let's get rid of these two and add in a new empty. And the new empty is going to be called bullet spawn. My bullet spawn, let's just go to the enemy and we'll do an override. So we'll apply to all enemies. All enemies now have a bullet spawn. But let's pull that bullet spawn down so that it is just below the enemy location. So just below the enemy. It's on the y-axis, minus 45.45. So that's where the bullet is going to come out of the enemy. Okay? Bullet spawn. And it's got to be somewhere where it's outside of the collider of the enemy itself. So bullet spawn should not be inside the collider. Okay? The other thing I want to do is modify the script, the enemy behavior script, all right, to include the bullet spawn. So let's add another section. We've already talked about a section for my enemy movement. Let's do another section, another header that's going to include things for bullets. Okay. So the first one is some kind of transform for the bullet spawn position itself. Okay. So I want to get a reference to the bullet spawn. The other thing I want is a couple of things. I need the prefab information for the bullet itself. So some kind of public game object for the bullet prefab. So I need a bullet prefab to generate the bullet. We're going to do it the old way first. Okay. And what I'm going to do is inside of my code, what we're going to do is we have an update, but I'm also going to make it so that I have in the same function a fixed update. Now, there's a number of ways to do this with update and fixed update. I'm going to make a delay here as opposed to using a coroutine. In a future video, in a future time, we're going to use a coroutine instead of this kind of delay method. So the way the delay is going to work is it's going to say if time.frameCount percent some value, let's call that value frame delay. Okay. Some number of frames that I'm going to count, counting frames. So some frame delay is equal to 0, right? So that means if I don't have a remainder, so let's say, for example, my frame delay is 10. That means every 10 frames, I'm going to fire off a bullet. Okay, that's what I want to do. So the way this would look like is let's make a temp bullet, and that's going to be instantiate, and I want to make a new bullet prefab. Here it is. And what I want to say is temp bullet dot transform dot position is going to be equal to the bullet spawn dot position. Okay, so that's what's going to happen. So when I create a bullet, every frame, it's going to wait. As an example, the fixed update is going to trigger on the physics update. And every time it triggers, it's going to wait X number of frames to generate a bullet, right? And then it's going to position that bullet in front of the bullet spawn of the enemy ship. Remember that bullets take care of themselves right now. They get, here's the instantiation, but bullets also destroy themselves, okay? This is the old way without optimization. What we need is to figure out frame delay, the bullet prefab, and the bullet spawn. Okay, a couple of these things can be figured out by dragging and dropping. Let's do that now. So going back to the enemy, you can see that I have a box collider here. Let's go into, first of all, let's override and apply to all. And I want to go into my prefab for my enemy just for a second. Okay, so in my enemy prefab, I have my box collider below my script. I don't like that. I want to move this up here, and we can close it down. And then when we leave this and go back to the enemy, you can see that that's been rearranged. I have my bullet spawn here. Bullet spawn is actually part of the enemy itself, so that's okay to figure out. And the bullet prefab is also part of the prefabs folder, and that's okay to figure it out, right? Frame delay, we'll start off with 10. That's every 10 frames. And we'll say that let's override the regular behavior. Okay, so that's enemy. The enemy is going to have a bullet spawn location, which is here in front of the enemy ship. And then at the enemy ship, it's going to instantiate a bullet. The bullet is going to stream down the area, and once it passes by the bottom of your screen, it's going to kind of teleport, or sorry, destroy itself, and it's going to do the instantiation and destruction. Let's try this out and see if it works. So play. And there we go. And you can see how the bullets leave and the bullets come back, right? As you instantiate, we can see that on average, we have about sometimes as many as 20 bullets, let's say, per. Okay, if I add more enemies, now I'm instantiating and destroying at the same time a bunch more. And it looks like they're going to be timed around the same. And the reason for this is because it's based on frame count, not on some other random delay. Doesn't matter. Okay, for now it doesn't matter. But the problem here is that we have a lot of bullets, and there's a lot being instantiated and destroyed every frame. This can cause a delay in terms of our performance, especially when we only have 4 ships, we have a lot of bullets on the screen, as an example. And if there's more enemies, then it can get pretty harrowing. Okay, you can see the bullet counts are huge. But this is all being instantiated and destroyed in real time. Okay, we can do better than this. We can do better. We can use the same structure. Instead of doing instantiation and destruction the way this is being done, we can use a bullet pool. So let's make those modifications. So how does a bullet pool look? Well, we need a class for that. And I'm going to make a new script called the Bullet Manager script. Let's call it Bullet Manager. There's a Bullet Manager class. Wonder how many bullets a phone's memory can handle. Well, these bullets are very simple. There's no sound. They've all got colliders, every single one of them, right? They've all got a texture. and they're all getting instantiated and destroyed every frame, pretty much. Something's happening every frame where there's instantiation and destruction, which means lots and lots of fragmentation. Over time, this could cause a real issue with the phone. Okay, so how do we structure the bullet manager? Now, here's what I'm going to tell you. I'm not going to use a singleton here, okay? We're going to use singletons in another lesson. So system.serializable. We're going to make the bullet manager available anywhere, okay? And for the bullet manager class, I want you guys to think about the requirements of what I need, okay? So one is I'm going to use a structure to hold the bullets. So I'm going to use a public queue of type GameObject. So remember what a queue structure is. We're going to call this the bullet pool. A queue is a collection that uses first in, first out structure, okay? Real enemy isn't the player, it's the player's phone. Even when the bullets don't hit, they still do damage to their true target. That's right. I agree. It's bad, but we're going to make it better. So the queue is what we're going to use. We're going to use a queue as a collection. So this is the bullet pool collection. And the pool uses, like I said, a first in, first out kind of structure, all right? And that means that bullets are lining up to be triggered, to be fired, okay? What I want now in the start function is I'm going to say, hey, bullet pool, I want to instantiate a new queue of type GameObject. So this creates an empty queue. Okay, that's what it does. An empty queue. It's a container. It doesn't have anything. But what we're going to need now is some kind of, function to build the bullet pool. So let's call it build bullet pool. So again, private and void, and it will be called build bullet pool. Okay, and the build bullet pool function we're going to call in the start. And what it's going to do is it's going to use a for loop, and it's going to go from I is equal to 0 to some kind of upper limit. So we're going to have a bullet number. So again, let's do this. We're going to say max. Let's just redo this in a second. Hold on a second. Let's go back to do that. The for loop's waiting for input. We'll just do it up here. So I'll say public, and again, it'll be an integer, which will be bullet number. We can also call them maximum number of bullets or whatever, but this is fine. A bullet number, some bullet number that we're going to have. We also need, let's just do all the needs. We also need a reference to the GameObject, which is the bullet prefab, because we have to generate the bullet now. Okay, so in our bullet pool, let's try that for loop again. So for, we're going to say that in the upper value, it's going to be some kind of bullet number. And we're going to say that when we create our bullet pool, we're going to use a temp bullet again, where we're going to instantiate, right, the bullet prefab. And we're also going to set the bullet to inactive. So when we create the bullet, it's going to be set inactive. It's not going to be active, right? And what we're also going to do is on queue the bullet. So bullet, temp bullet, bullet pool dot on queue. On queue is like pushback equivalent, but instead of this one, it's so you push to the back and then you pop from the front. That's how a queue works, right? So on queue, we take our temp bullet and push it onto the queue. Let's just see how this works, okay? And we need a structure to kick off Bullet Manager, because Bullet Manager is not a singleton. We're going to attach it right now to a game object that we have available in our scene. So if I go back to Unity, we have a game controller, and the game controller has a game controller script. When I run the game controller, you can see that what it does is it keeps track of our, the safe area in the screen. And later on, we'll use this. Let's dim out the player for now. So I'm just going to deactivate the enemy, And what I want is for my game controller, the bullet manager to be attached to my game controller for now. Let's set up a number of bullets as 50. And I want my bullet prefab to be under prefabs, the enemy bullet. When I run it and kind of start off, you're going to see that I have 50 bullets that have been created, and they're all inactive. If I turn one on, you're going to see that it triggers. Okay? Except notice that it disappeared as well because it destroyed itself. That script has to change. But for now, let's continue with the bullet thing. Also notice one more thing. When we instantiate the bullets, they kind of go into my hierarchy really ugly, and this is terrible. What I would rather have is all of these bullets to be somewhere inside the game controller or somewhere else. So for that, let's go back to our script. And what we're going to do here is we set inactive, but we're also going to say that the temp bullet, right? I want to have my transform.parent equal to the transform of the game controller. Because right now, this function, this class is connected to my game controller. So if I run this again, you're going to see when I generate the bullets, they're all going to be appearing underneath the game controller. Because my transform.parent is now the game controller. By the way, there's other ways to do that. You can say, instead of temp bullet transform parent, you can also say temp bullet.transform.set parent to transform. You can do it this way too. You can use the setter. It's the same thing. So this creates the bullet pool. But what I want is a method to remove a bullet and a method to return the bullet back to the pool. So let's do that. So we're going to make a method, but this one is going to be public. And the public method is going to be void. It's going to return a game object. I think I want to keep the game object being returned. You don't have to have this, but it's going to be called getBullet. And I need to know a vector to location of where the bullet is going to be spawned. Okay? So the way we can write this function looks like this. Var temp bullet. That's equal to, hey, bullet pool, I want to dequeue a bullet. So what dequeue does is it removes the bullet and returns a reference to the bullet itself or the game object and stores it here. So notice that temp bullet is actually going to become a game object now. When it returns the bullet, what I want to do is I want to set the bullet as active, right? Set active. But I also want to set the bullet's position to the position that's passed into the function. So this position here is going to be passed into the bullet position. So it's going to reposition itself where I tell it to, which is going to be the bullet spawn location. And then just to get a reference, to keep a reference to the bullet if I need it for whatever reason, I'm going to build this in so I can return a reference to the bullet itself. I won't need it. But if I do, if I want to use it later on, if I want to access the bullet, I can do a bunch of stuff with it later on. And that's why I want to return it. Just to be preemptive, I want to return a reference to the position. If I don't use it, it'll just go into the bit bucket in the sky. It won't be used. Same way, I want to have a public function that's called return bullet. Okay? And I want to give a reference to the game object, which is the bullet to be returned. We can also call this return bullet. Returned Okay. And the return bullet, I'm going to say, hey, return bullet, let's set active to false, right? So we're going to set the bullet false. So it's not going to be in the scene anymore. And we're going to say, hey, bullet pool, let's on cue it again, right? Let's on cue the return bullet. So it's going to be returned back into the pool. So this one kind of removes a bullet from the pool, right? So this method returns a, removes, we'll say, a bullet prefab from the bullet pool, right? That's what it does, and returns a reference to it. Okay, and this method, it returns a bullet back into the bullet pool. Okay, so removes it, returns it. Okay, and we'll say this method here, this method builds a bullet pool with bullet number bullets. Let's say, yeah, it's good enough. Okay, so that's kind of some documentation, right? That gives us a sense of what to do. We don't really need the update function, so let's get rid of that. So no more need for an update function because this class doesn't need it. Again, we want to remove any unused functions as much as possible. Okay, cool. So how do I use this now? Once I made the bullet manager, I want to use the bullet manager. So can I go ahead then in my enemy behavior, right, where I use bullets, right? First of all, I don't need a reference to the bullet prefab anymore. Okay, that's the first thing. Because the bullet prefab is going to come from the bullet manager. So I can remove this altogether. I'm just going to comment it out so you can see what's been removed. Okay. And then inside of my frame count, I'm still going to use the same delay method. Let's just comment these ones out. I want to call the bullet manager to do that, but I have a problem. I can't say, hey, bullet manager, use the bullet manager thing to, get bullet. I can't do that, right? Because the bullet manager, in this case, has never been instantiated. I can't use, there's no static method to do that. And if I use a static method, right, then it might be that I'm calling the bullet manager when the bullet manager hasn't yet been created, right? So what I want to do is get a reference to the bullet manager first. Okay. And in order for me to do that, I'm going to do it this way for now, but later on, we're going to make it a singleton. And we'll actually create a factory. Singleton factory is what we're going to make in a later video, right? Which is going to make a lot more sense than what's happening right now. But we're going to do it in small steps so that everyone understands how all this is happening. All right, so what I want to do here, up here near our bullets, we remove the bullet prefab, but what we want to do is get a reference to the bullet manager itself. So under here, I don't want to make it public. I can make it private because we're going to make a reference that is automatic. So we're going to say bullet manager. And in here, in our start method, we're going to say something like, hey, bullet manager, we want you to use the GameObjects class to find object of type, and it's going to be of type bullet manager. So that gets a reference to the bullet manager that's in the scene. Again, it's only temporary. Once I have a reference to the bullet manager, well, now I'm cooking. Because now down in here, I can say, hey, bullet manager, right? Hey, bullet manager. I want to make a var temp bullet if I really want to. I mean, if I want to, I can make a temp bullet, and I can actually equal to the bullet manager. But I can just say, instead of instantiate, I can say bullet manager dot get bullet. And I can tell it where it's going to go. It's going to go to the transform dot position of the bullet spawn, right? So bullet spawn dot position. So that's where it's going to go. And so you can see that there's no instantiation anymore. I'm just using the get bullet method to do that. Well, my problem is it's not over yet. What I need to do is, if I want to, instead of destroying the bullet like I do in bullet behavior, right? In bullet behavior, I have speed and bullet bounds, and then at the end I destroy my bullet. I don't want to do this anymore. So I don't want to destroy my bullet anymore. I want to return my bullet. But again, just like before, in enemy behavior, I don't have a reference to it. So again, I'll just grab the same script, go back to my bullet manager, my bullet behavior, and at the top, I'll say that, hey, bullet manager, I want to get a reference to it. And I'll do the same script that I have here. I'll put that in the start function. And now, instead of destroying, when my bullet leaves the bounds of the screen, I will use my bullet manager dot return bullet, and I want to return this dot game object. So that's a reference to the bullet itself, this one. Just like I'm destroying this game object, I'm returning this game object. Okay? So a couple of swaps. I've swapped out a little bit of code. Let's go over it one more time. So my bullet manager, again, there's a few things. I'm using a queue, right? And a queue structure, remember what it's like? It's like a lineup, right? Where I have an empty container in the beginning. That's what this does here, an empty queue. And then I build the bullet pool by adding X number of bullets, however many I said. If I want 50, 100, 200. I pre-spawn or preload all the bullets I want, but I set them active false so that they're not going to be shown in the scene. Their colliders aren't going to be working, none of that stuff, all right? But I also parent them to the transform of the game controller. And then I on-queue them into the pool. On-queue means I push back, all right, equivalent. And then when I get a bullet, I pop front, which is kind of what I'm doing in a queue in C++. DQ is like a pop front. I pop the bullet from the front of the pool, and I return a reference to it, okay? Set it as active, set the transform position as the position that the user passed in for the spawn position. To be clear, I probably could rename this just to make it even clearer. Let's rename. We'll call this spawn position, okay? ReSharper doesn't like this. It's going to ask me to do spawn position. That's fine. Same thing with return bullet. It doesn't like return bullet. It likes return bullet. By the way, I'm using ReSharper C# in this case, not C++. All right, so that's pretty cool. It does all those things. And so there's two functions: get bullet, removes a bullet, return bullet, adds it back in. Okay, let's see it working. And a couple of things we need to do for the game controller for it to work, right? One thing we need to do is we need to get a reference to the enemy bullet. We did that, my bullet manager, right? And we need a position for first of all, nothing will happen yet until I bring the enemy back. Let's bring the enemy back, and let's see if it actually works. So let's play. And there you go. Same as before. But you can see what's happening here. it's kind of really cool and visual. So the game controller, you can see that these are all inactive bullets. And then now these are all set to active. And as they leave the screen, they become inactive. So they kind of move down the screen. Okay. And this is okay. And it's not going to run out of bullets because you have plenty of bullets in the pool. All right. What about if I put in a couple more enemies? So let's load a couple more enemies in there. Is the number of bullets enough now? Well, maybe not. So you can see that I'm using all the bullets now, and there's going to be a point in time where I get a reference that says, hey, my queue is empty. I can't pull another bullet from the pool, right? So that is an issue. So I could, for now, go into my game controller and figure out, like, you know what, I probably need about, at least 20 to 25 bullets per. That means I probably need double the amount of bullets from my game controller. And I can put a number there. Okay, that's a temporary solution. But there's another way. And the other way is to dynamically increase the bullet pool size, right? If I need more bullets than it exists, I can instantiate a number of bullets, and I can increase the bullet number accordingly. So whatever that bullet number is, I will add more bullets to the pool, and I will increment that bullet number. So during runtime, us as a tester, we can see that number climb to the right number, and we can figure out a rough estimate of how many bullets are required per enemy, right? So we don't over provision too many bullets, all right? So let's try this out. Is 100 enough? Let's see if 100 is enough. I'm guessing that 100 is going to be enough, but the way you look at it is if you can see that there's bullets left in the pool, this looks like it's going to be okay. Because see how there's inactive, active, inactive, active, right? It's pretty close though, right? Because you can see that as it moves down the screen, it's pretty good. So 100 bullets should be about right for 4 enemies. I figured about 25 bullets per enemy. Performance-wise, it looks pretty good. And here, all we're doing is we're using bullets. We're using the bullets over and over again instead of instantiating and destroying. Bullet Pool 101. All right, questions around the bullet pool. Let's put this up on GitHub. File, save project, and close it off. So things for optimizations that you can think of. What about creating a, and this is for you to try when you do your lab 3. This is all you need for lab 3, right? So let's view changes. Let's stage all the changes, and we'll say added bullet manager, right? Commit all, and then push. You can add dynamically allocated bullets. So you can say that if my bullet pool is low, right, I need bullets, pull as many as you need. In fact, what you can say is, right, if there's no bullets available, right, start off a pool if you want to really test it with no bullets, 0 bullets. So I'm pulling, something from the pool. I'm getting a bullet, but there's no bullets available. Then what do? Generate one. So the first time an enemy asks for a bullet, and every time thereafter, if there's no bullets left in the pool, right, ask for bullets. So that's something that you could do. The bullet pool will grow dynamically, and it'll stay that size, whatever that size is. If I need more bullets, it'll grow. We can try it out to see what it looks like. Again, it's outside the scope of what we're doing today, but we're together, and why not? Let's see what happens. So instead of loading it up first with an X number of bullets, don't build the bullet pool with any bullets at all. Start off with 0. Okay? So it's a bit of a different script. Let's see how that works. So here's Bullet Manager. So we have a build bullet pool, right, as an example. And this instantiate, set active, transform parent, blah, 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 all this stuff right now is something that we're going to do every single time. We can actually create a new function. So we're going to extract this method where we're going to add a bullet to the pool. We'll call that add bullet, right? We'll call it add bullet. So add bullet is something that we can do with a bullet pool, build bullet pool, or we can do it dynamically. Let's do it dynamically instead of calling build bullet pool, right? Let's think about this. It's going to try and get a bullet from the pool, right? It's going to try and do that. But the bullet doesn't exist. I can't dequeue. So first thing to do is check to see the size of the pool, right? So I'm going to say something like if, bullet pool dot, can I do a size? Can I do a count? If my count is greater than 0, right, then go ahead, do this and whatever, and return the bullet. So dequeue. So do this, dequeue, right, whatever, and then all this kind of stuff, right? Well, what if it's not? Well, first what I want to do is, do that first and then dequeue. So really, it's not this. It's this. If it's less than 1, if the bullet pool count is less than 1, so 0 or less, right? And by the way, you can have a different threshold. Instead of 1, maybe you have less than 5, right? As an example, generate 1, right? Because it might be too slow. We'll show you this in a second, right? Remember, we're going to be accessing the bullet pool multiple times. So if it's less than 1, so there's nothing left in the bullet pool whatsoever, then make a bullet. Add bullet. Okay. So add bullet will add a bullet to the pool, right, as much as possible. And then what we want to do is our bullet number is going to really be there to count how many bullets are in the pool. So let's say bullet number plus plus. Okay. Different way of doing it. Okay. So we're start off with 0 bullets, but when I need a bullet, make 1. Okay. And only do it when there's less bullets in the pool than I need. Okay. In the beginning, we're going to do this a bunch. And the question for you is having no bullets, is that even possible? Or is it going to be a real issue? So let's go back. And let's go to our game controller and adjust the numbers. So our game controller says there's 100 bullets. Well, right now we're going to make it 0 bullets. Okay, so 0 bullets counting. We have 4 enemies. Let's run this thing and see what happens. Does it crap out, right? Well, there you go. Right now we're sitting at about 44 bullets, right? And 44 bullets was enough. Now it's 48. And you're going to see that it varies over time depending on the number of bullets that I require, right? But you can see it stays stable after a while, right? So it comes to a point where we're not going to run out of bullets and we get a much nicer value. So the first set of bullets that get created, there's a bit of a cost to them, right? But later on, you can see that not as many get created later on. But this way, our bullet pool will never be empty, ever. And we can reuse the ones that we have later on. This is a different way of optimization. 76 for four enemies seems to be the right number. Not 100. That's a better optimization than 100 bullets. It's less, although we paid for it up front. Okay, let's add more. So 76 seems to be the right number. Let's add more enemies. All right, so let's add more enemy prefabs. Okay, so 7 enemies, 8 enemies, 9 enemies, 10 enemies, 10 enemies. Let's see what that does for us. Can it handle that many all at the same time? And let's see how many bullets we're going to use now. We're at 140 already. Okay. I mean, it's bullet mayhem. Okay, but the idea is that we're at 150. Okay, for 10 enemies. So that's like the number. We don't know exactly how much we need, right? So here's a question I'm getting from Kira. Would there be a benefit to adding to the pool in batches rather than just adding one at a time? Well, yes, but we could definitely do that. That's a great idea. And the advantage of doing that is we're going to have a lot more range. On the downsides, it won't be as accurate as this, right? So for example, we know we're stable around 170, right? With your batch system on the downside, on the downside, when we did 270, we paid for it in advance. We had to instantiate 170 bullets during gameplay, right? And that's a negative, right? It's 117 for 10, which is roughly 17 bullets per on average, all right? So, I mean, that means if I add an enemy, the other way to think about it is if I have, for every enemy, add 20 bullets or 25, whatever it's going to be, right? That's a safe way of doing it as well. Oh, we're at 190 already. Look, that wouldn't have been enough. So it looks like, again, probably around 19 bullets to 20 bullets per enemy. We were right. That's the right way. Your way, advantage, less instantiation, again, throughout the entire time. Disadvantage, again, you might end up with more bullets in the pool, as an example, compared to doing it this way. So I'm not saying it's a negative thing, right? And again, for Unity, you probably won't notice it, okay? But when you're running it on a device, that's the real test, okay? That's the true test. And we can also look at the memory profiler and see the difference. We'll talk about the memory profiler in another video. So again, it looks like we're stable at about 190. And what about if a more enemy comes in? Let's bring them some more enemies as they come in. Let's see, does that, grow even more, even it's more insane than it is before? Well, yeah, we can see that we're about 192. Now we're gone to a 224. So it's, again, more dynamic as we go through. 224 bullets is 256 bullets in our pool, right? Roughly is what we need. And it could be more because I've added some extras. And remember, over time, we might need more requirement depending on the timing, because it's approximately every 10 frames. Let's just keep going. See how many of this can take before it breaks. Let's just make it all white. Okay, full of bullets, full of enemies. Here's something else that we can try again. So this is kind of an interesting test. The other thing we can also test is Control D. What we can also do is try and use instead of an object pool for bullets, we can use an object pool for enemies, right? And now we're talking generics, right? Because we have the same functionality that we had before. We're going to be able to grab an enemy from the pool and instantiate it, right? Similar to bullets. And we're going to be able to return an enemy back when it's destroyed. Okay, so if I destroy an enemy, I put it back into the enemy pool. So I could create another class that inherits from, a generic, generic type. In fact, we don't have to even make it generic because it's the exact same structure. Let me show you. And I'm not going to do that right now because it's out of scope, but I want to kind of just show you the code. So for my bullet manager, the only thing it requires, really, if you think about it, right? I mean, the name's bullet manager is there, right? Yeah, we could do that. Poolable object, sure. I love it. An interface. But take a look at this. Bullet manager itself, the queue, this is where your interface would come into play. So instead of a game object, it'd be a special type of object, a poolable object we can create. And so instead of a bullet pool, we would call it an object pool here instead, right? And instead of a bullet number, we'd have an object number, right? And we'd have a object prefab. So we just change it to object instead. And then we could reuse this stuff, add object, get object, return object. We just rename this thing and it'd be generic, and we can attach it to any one of the things I want. I can add this multiple times, and I can point to different prefabs. And so then what I can do is I can have an object pool for enemies and an object pool for bullets. So good, really good from a utilization perspective. And now we come back to that whole thing, which is what if I wanted to use an object factory where I can send an object request to the factory. I want an enemy, I want a bullet, I want whatever, and it returns back whatever I'm asking for. We're going to be talking about factories in kind of another video. And again, if you look at our schedule, the next thing we talk about next week is the factory pattern. And this is where we're going to actually do factories of bullets. And we're also going to be at the same time, we can't talk really about factories without really talking about, to really do this properly, without talking about singletons. So we'll see singleton and factory next week. Questions around this stuff? Again, the dynamic pooling example is not required. And, again, we'd have to test to see if it's actually more efficient than a static number of bullets. And I recommend to you that testing it this way is cool, but putting in a number of bullets, if we know that it's approximately 20 bullets per enemy, right? Trying it the other way around might be better from a performance perspective. Okay. Okay, that's my hypothesis. We'll see if we can test that out another time. Any questions before we end for the day? Okay, that's it. I'm going to stop recording this on YouTube, and good luck. I'm going to also put the dynamic pool up online to show you the difference between what we did with the static pool and the dynamic pool. All right, thanks a lot, guys, and we'll see you next week. Take care, guys.